Okay, these are notes for Thursday, October the 28th. These are our notes for finding the x and y intercepts. We discussed today in class how we use x and y intercepts to graph lines, and we're moving into our Unit 4 now, which is our Unit 3, which 3, 4, and 5 actually are all of our Chapter 5 in our textbook, which is graphing. So we're starting out our graphing with intercepts. We're going to have our y-intercept. And the y-intercept is the y-coordinate of the point where the graph crosses the y-axis. The x-coordinate of this point is always 0. So what that means is if you have an ordered pair and it is the y-intercept, then your x value in it is going to be 0, and then the y value would be something else. So likewise, if we have our x-intercept, is the x-coordinate of the point where the graph crosses the x-axis. And the y-coordinate of this point is always 0. So in this ordered pair, it's going to look like this. There would be a digit first and then the 0 second. So this is how we use the intercepts method to graph a line. First, we have to figure out what the intercepts are. So I'm going to find the x-intercept and the y-intercept for each one of these problems. And I probably won't do all the notes. So the kids did a great job today, and I think just a few examples will be enough. So I'll do A, B, and C, and then maybe the last two. So what we've got here, x and y-intercept, that means, like I showed you just a second ago, that the x-intercept has a 0 in the y position, and the y-intercept has a 0 in the x position. So I'm going to use this equation and do some substitution to figure out what my missing amounts are. If I have the equation 3x minus 2y equals 12, I know that y has to be 0. So I'm going to replace the y with a 0 instead. And if I multiply negative 2 times 0, I actually get 0, which means this term really isn't there anymore. If I write down what's left, if I write down what's left, 3x equals 12, then I know x equals 4. And that gives me my x-intercept. That means this graph crosses the x-axis at 4, 0. Let's do the same exact process for the y-intercept. If I have 3x minus 2y equals 12, and this time I'm going to take the 0 and plug it in for x, it would look like this. Of course, that goes away because you've got 3 times 0 would be 0, and therefore you really wouldn't have to write it. You end up with negative 2y equals 12, and if you divide by negative 2, y equals negative 6. So there's your y-intercept. 4, 0 is here, 0, negative 6 is there, and then we graph it together with a big long line going all the way across the graphing grid and arrows at the end. That's how you graph a line using the x and y intercepts. All right, let's try another one. Same process. Going to find the x-intercept first, find my y-intercept second. I write my kind of little skeleton step here where I fill in the numbers. I know my 0 goes there and there for the different intercepts. All right, let's start plugging it in. This time I'm going to go ahead and actually plug in the 0 for where the y is, like this. Kind of just saves myself one little step because I already know that y is going to change to 0, so I'll just go ahead and write it down the first time, which makes that go away. I end up with negative 3x equals 30. Therefore, x, when I divide by negative 3, equals negative 10, and that's my x-intercept. Let's do the same thing on this one. This time the 0 needs to go in for x, so it's going right here by the negative 3. I multiply that out, which makes it go away, and I've got 5y equals 30, so y equals 6. Negative 10 would be over here. Positive 6 would be there. Graphing my line. And that's it. So once we got to the third example today in class, some of the students were starting to ask, wow, we skipped a step on that last one. Are there several steps we can skip? Now, I don't always encourage students to skip steps, but with these, they're pretty easy little problems to solve. So if you're comfortable, whoops, I messed that one up. If you're comfortable and you think that you can do the problem without showing every single step, I think that's a great mental math process that you can go through. Let's see if we can skip a step on this one. Skip a couple of steps. I'm going to put my zeros in the correct place. Now, if I was to take this 0 and plug it in for the y, I know that's going to make the y term cancel away. I would end up with 4x equals 16, and if I divided by 4, there's my x-intercept. All right, let's do the same thing again. This time let's put in the 0 for the x. If I put the 0 there, I know that will cancel away. I get 2y equals 16, which means y equals 8. I don't encourage, but I do suggest that maybe some of the students, if they're ready for it, this is an easy process. You just have to be really careful. Make sure you put your 0 in for y on an x-intercept. Make sure you put your 0 in for x on the y-intercept. 4, 0, 0, 8, connect, and there you go. Now, I said I wasn't going to do D earlier. I changed my mind. We actually had an example on our assignment today that some of the students struggled with a little bit because it wasn't written in standard form. This equation right here is in what's called standard form. AX plus BY equals C. The letters A, B, and C in there just could represent any number that you want to put in. But standard form, puts the A and the B on the same side of the equal sign, and then the equals, and then another number there. That's standard form. But we had a problem on our assignment today that looked like this. Y equals 4x plus 8. And so you can find intercepts putting it in there just like this, but a lot of the students said, hey, could we make this equation look like the ones that we've been working out in our assignment? I said, I think that's a great idea. If we could just take this 4x and make him come over here in front of the y like he's supposed to be, it would be in standard form and it would work out like the others. So to move a term, we know we always do the opposite. Subtract 4x. So you end up with negative 4x plus y equals 8. So one tiny little step and he was fixed. We've got our x-intercept, we've got our y-intercept, and then you do the process again. If I take this x and I plug it in for y, that would cancel away. Negative 4x equals 8, which means the x is negative 2. If I do the process again, putting the 0 in for the x, that term cancels away, and I end up with y equals 8. So I've got negative 2 here, 8 there, graph. Whoops, that line got crooked. Let's try that again. 8's up here, negative 2's down there. Let me start from the top. Maybe that'll be easier. Connect, put your arrows, and you're done. And finally, sometimes we're going to be asked to tell what the intercepts are just based on the picture. I can look with my eyes and see an intercept there, and then I just list out their ordered pairs. Negative 2, 0 would be the x-intercept. 0, 1 would be the y-intercept. For this one, negative 2, 0 would be the x-intercept, and 0, 3 would be the y-intercept.